Hi students, today we are going to see the chapter motion of class 9 CBSE. So let us fastly see what are the areas that we are going to cover. So with this presentation, so we start with the motion as shown in the presentation, right? So we'll describe motion. So what is distance, what is displacement and all. Then some of the examples of motion we cover. Then we have different types of motion, uniform motion and non-uniform motion, and we distinguish them, okay, with their respective definitions. Now we have some examples to quote what is uniform, non-uniform motion and all. Next, we describe speed and of course velocity, and we mathematical definitions of the same. That also we look into it. So velocity as displacement by time and all. Then very importantly, we talk about average speed. Okay, so that is generally calculated in some of the numericals, right? So then we see some of the example problems, a few. Then we talk about velocity because the velocity and the speed are different. So we define velocity, and again the same like average velocity, just as in the case of average speed, average velocity. Then some of the examples are related to the example. And then we have acceleration, which is a derived quantity from velocity. So that's what we see in detail, what is acceleration and all. Now, yeah, we have some of the examples of acceleration, and there are some graphs important, okay, with regard to exam analysis like distance time graph and others, so which we analyze, and with few small derivation of the same. And we have equations of motion like from the either from this I mean to say either from graphs, or we can generally evaluate. We have different equations of motion. We'll see the derivation part of it. Finally, we end up with the circular motion. That is the topic. So where what is circular motion and how the velocity changes in the case of circular motion. Let us fastly go ahead with the motion, that is motion. So we know that humans, and not humans, all of the world rather, like so it will be in the phase of motion, or it will be in the state of rest. So if I have to exactly define what is motion, it is a change of position of a body with respect to time. So that's what we define. So always time is the main parameter of interest. So with respect to time we define. So therefore motion is the change in position of the body with respect to time. So it can be described in terms of the distance moved also, or displacement. So because yeah, it results in either distance or displacement, whereas distance moved is the total length of the path or actual length of the path that traveled by the body. Displacement is the shortest distance traveled by the body from initial position to final position. So that is what is the difference. Now some of the examples include like see, not necessarily these, but anyway, in nature also we find when it comes to motion, so many examples like wind blows. Okay, automobiles, they move from one place to another place. Water flows from one movement to one position to another position. Like that, so many examples we have. Now here, coming to some day-to-day examples, which generally we come across, like examples of the motion. Car will be in motion, and of course, a train, you can see a local train, right? So therefore, whereas that is called linear motion, if you have some inclined path, the path changes, then motion of the ball that we see in that this one slide, that is downward, that is also called an inclined plane. That also we can observe. Now, if we have to see, if once motion is defined, then how many varieties of motion that we can have? See, there are basically two types of motion based on the distance covered with respect to equal intervals of time. So with regard to equal intervals of time, the distance traveled, if the body travels equal distances, then is said to be uniform motion. As the name uniform implies, same. So therefore, on the other hand, non-uniform is the body travels unequal distance at equal intervals of time. So we can take an example that within a second lapse of 10 to 20 seconds, say 20 seconds, if the body travels, for every 20 seconds, if the body travels, say 50 meters, then we can say it is the distance is uniform. That means the speed is uniform. The motion is uniform rather. So every 20 seconds, if it is covering 50 meters, so 50 meters per 20 seconds, which is uniform. On the other hand, if the every 20 seconds it's being changed. For example, initially it is 50 meter in the first 20 seconds, and later on it changes to say 100 meter in the next 20 seconds, coming back to 40 in the next 20 seconds. That's how it is changing. Then we'd say it's not at all uniform, rather it is a non-uniform motion. Some of the examples of uniform motion, you can take the movement of a clock's hand and movement of pendulum is the example of uniform motion. And movement of asteroid and the bouncing of a ball is the example of non-uniform motion. Asteroid, generally we find some of the comets and asteroids, so it is quite non-uniform, we can say, because of the terrestrial atmosphere and the changes in the terrestrial atmosphere. So the frequency, I mean the friction offered and are so many factors in the pressure, the atmosphere, so many factors are there. So therefore it is non-uniform. The distance covered is not at all uniform. Okay, now that means the speed increases, right? And coming to the example of non-uniform motion, one more, bouncing of a ball, that also see, bouncing of a ball, if you look at, it will not cover equal distances in equal intervals of time, it changes. We might have regularly observed. Now coming to speed, as shown in this one slide, speed is the change in the displacement, change in the distance with respect to time. So therefore, it is a distance traveled by the body per unit time, and as mathematically we can define it as distance by time. So if a body travels distance s in time t, then the speed, though not represented exactly by v, but it is distance by time. Okay, so speed or velocity, but only thing is speed is a vector, it's a scalar quantity, and on the other hand, velocity is a vector quantity. Now, SI unit of speed is meter per second only. The same unit equally goes with velocity, but only thing is it's a vector quantity. Now, speed has only one magnitude, and as I told you, it's only magnitude. It has no direction. Now, if you see the example, you see the red car is at the speed of 30 meter per second, and the gray car is at the speed of 40 meter per second, and it is leading. Gray car is leading the red car, right? Because the speed is more, it is leading. That's how it goes. Next important parameter is average speed, because speed, if you compare with time, with respect to time, is not consistent. Now we cannot say it is always, there is no chance that there is very few are the chances that the speed are consistent. So therefore we have to calculate the speeds over a given period of time, see how much. So if the speed continuously changes over a period of time, then we will be taking a parameter of interest called average speed, so because the speed is not constant. So defined as the ratio of the total distance to the total time taken. So mathematically, average speed is the total distance by total time taken. Then only mean value or average value will come. Some of the examples include, like if you have a car traveling 85 km from point A to B and then 45 from point B to C, that means distance covered is not uniform. The total time took was around 1.3 hours. What was the average speed of the car? So here actually it covered 85 from point A to B, and from point B to C it is 45. Total distance traveled is 130 km by 1.3 hours. So around exactly in terms of kilometer per hour, we can, yeah, it is approximately 100 kilometers per hour is the speed of the vehicle. So that's how we calculate. Next, velocity, as I just told you, it is just as speed, it is a change in displacement by time with respect to time. So therefore velocity is the rate of change of displacement rather. Okay, so it's a vector quantity very much because it has got both magnitude and direction. Now some of the examples you can see, actually there is a specific direction in which each and every case the cars are there. So they have a specific direction, like 30 miles per hour, 60 miles per hour northwest. So that's what 60 miles per hour east. Two cars are going with the 30 and 60 miles per hour, and one is going with 60 miles per hour northwest. Directions are also exact. Now, in the previous case, when you see in the case of speed, that here it's not there anyway. Yeah, you can see, though. Yes, it's only velocity because direction is not there. We cannot give a particular direction. So if the direction is not there, then we say it is only speed. Otherwise, we have to describe it as velocity. Now, similar in the similar lines of average speed, average velocity is also the total displacements by total time taken. That's what we say average velocity is. So average velocity, we can say it is in terms of initial and final velocity, mathematically given as initial velocity plus final velocity by 2. It is the average or mean value of initial and final velocity, simply denoted by u plus v by 2. Okay, so that's how we can calculate average velocity given initial velocity and final velocity. Okay, next some of the examples, like if a car changes its speed from 10 meters per second to 20 meters per second in just 5 seconds. So change in velocity, that is initial speed and final speed. What is the average velocity? Initial, right? So we can take it as initial and final, and 10 plus 20 by 2, because initially it is going with 10 meter per second velocity and then 20 meter per second velocity. So we can have here average velocity, which is 10 plus 20 by 2, which is equal to 15, right? 15 meter per second would be the average velocity. Next thing is acceleration. Derived from velocity, there is another parameter called acceleration. Now it is a rate of change of velocity. So therefore, it is also can be mathematically given by, in terms of initial and final velocities, as v minus u. You can see final velocity minus initial velocity divided by, it's not 2, rather it is acceleration is equal to rate of change of velocity. So we say final velocity minus initial velocity by total change in the time. So there is mistakenly it's printed as 2. Now if the velocity of a body changes from initial to final, then acceleration is, you can see, sorry, it is v minus u by t. I just, yeah. Now it is total change in displacement by time, total time taken. So therefore we have to mention it is, yeah. So it is t, dt. Next. Now then some of the examples, you can see what is average velocity. If the body initially in the constant direction, increase speed. Now you can see bit A2. So 4 different ways to accelerate a car. Initially the car is going with 60 miles per hour, and then a car has reached 30 miles per hour velocity. That means there is a negative acceleration in the car, which is called retardation or deceleration. So whereas in the second case, in the B bit, the constant direction decrease in speed. No. Yes, you can see 30 miles per hour to 60 miles per hour is a change in, is an increase in speed. That's what we observe here. Now change direction, constant speed. No. So though there is a change in the direction, but the speed is constant. That also we can observe. 30 miles per hour is consistent, and 60 miles, again, change in the direction, increase in the speed, change in the speed. That also we can see in the fourth figure. Like different ways of acceleration. One is acceleration and retardation. Next thing is, very importantly, if we have what is a distance time graph. So if the distance is plotted against the time on a this in coordinate plane, that is y-axis and x-axis, right? Whereas distance is taken on y-axis and time is taken on x-axis. It's how the distance changes. So the function, if the distance is plotted as a function of time with respect to time, how distance changes. If you look at now, it can be represented on the distance time graph. So distance time graph for uniform speed is always a straight line, because we know equal uniform speed means equal distances in equal intervals of time. It's a straight line. Now next thing is, if you look at practical graph plotted, so in the case of uniform motion, the plot is a straight line starting with the origin. So it is the form of y is equal to mx. So a straight line y is equal to mx passing through the origin, and as you can see, y-axis distance is taken and x-axis time is taken. So distance is plotted as a function of time. So as the time changes, as the time varies, how the distance changes, that's all is observed from the graph. Next. So derivation of 3 formula of motion. Very importantly, we have fundamental laws of motion. For we have to define, we have to derive the basic 3 formula of motion. Now, what is that? If you look at it, a body is moving with the initial velocity u and with a uniform acceleration a meter per second square, it reaches a final velocity of v meter in second in a time lapse of t seconds. Then it covers the distance during that time. If it covers the distance, yes. Then actually first one, acceleration, you know, the units are meter per second square, and final velocity is units are meter per second, time in seconds and distance in meter. Now, the first equation of motion would be like it is a relation between initial velocity, final velocity v, initial velocity u, acceleration and time. So, as I just told you, v, that is final velocity, is the sum of initial velocity and product of acceleration and time. So, v is equal to u plus at is the first equation of motion that is described by Newton. Now, thing is, next, if you look at the other slide, the next one, yes. The second equation of motion is all about, it's a relation or function between distance and of course acceleration, initial velocity and time. So therefore, knowing that average velocity is v plus u by t and distance traveled is average velocity, yes, distance travel if you want, then we know that distance travel, to obtain distance travel, we calculate in this method. Like initially we calculate the distance travel due to initial velocity and then due to a change in velocity, that is acceleration. So we can say, because first equation we can very much put over here, that is v is equal to u plus at. Yeah, just now we have seen distance is equal to time. Yeah, distance is equal to velocity, of course. You see now u plus at is a velocity plus final velocity plus initial velocity by 2, average velocity into time, very much use the distance. Let us see. Distance is equal to, because average velocity is equal to distance by time, distance is equal to average velocity into time, so u plus v by 2 into t. So final velocity anyway, if you represent in terms of initial, u plus at plus u by 2 into t. So 2u plus at by 2 into t, that is 2ut rather, okay, and half at square. So 2ut by 2, it comes to ut only. So therefore, we have two components here. The distance traveled is a combination of ut, that is a component due to initial velocity, and half at square, a component due to acceleration. Now the third equation of motion would be, it is a relation between initial velocity, final velocity and acceleration distance. Now whereas s is the distance, we see now the same is the process. Like we start with the relation of initial and final velocities, then we have rating of the same equation. If you rewrite, then you get v minus u is equal to at and v minus u by t is equal to a, or a is equal to t. Now, once you replace this in the s is the second equation of motion, s is equal to ut plus half at square, then it is u into time. You can just mention v minus u by a and half a t square v minus u by t whole square. If you just expand, you get what? uv minus u square by a plus half a into, that is what, v square plus u square minus 2u by 2, that is yeah. If you take yes, it is v by 2 whole square, it is 1 by 4 rather, right? So that's how we can derive finally s is equal to v square minus u square by 2a, and it leads to a third equation of motion, that is v square minus u square is equal to 2 into a into s. That means we can say orally like this, it is the difference of squares of final velocity and initial velocity is equal to product of, it is twice the product of acceleration and distance. Now, so lastly we have a very, other than linear motion, we have to see as long as the body is moving in a straight line, we consider as a linear motion, and the velocity and what are the parameters discussed so far, they are applicable for the linear motion. But if the particular object is not moving on a straight line, rather they are moving on a circular path, then it is, we say it is uniform circular motion, because the body is, it is traveling on a circular path. So the motion of a body in a circular path is said to be circular motion, and now the difference is here the speed and velocity slightly vary at each and every point of time. In the case of circular motion, at every instant of time, the direction of velocity is it's along the tangent at that point to the circle. So therefore, uniform circular motion, it is defined as the name implies, if the body travels as equal. Okay, so yeah, it is uniform circular motion is accelerated motion, because in a circular motion, a body is continuously changes its direction. As I just told you, at each and every point of time, the direction is changed, and it is in the direction of the, it is in the tangential direction. So therefore, direction is changed. So therefore, because the direction is changed, we say velocity, the magnitude of the velocity also, it is changed. Okay. and no, therefore we can say it is acceleration motion. So it's an accelerated motion, and of course to find the total velocity here, distance by time, the total distance traveled here is the circumference of the path with a radius small r. A circumference of 2 pi r is covered in a time lapse of say 2 minutes or 2 seconds, whatever it will be, 2 seconds typically. So 2 pi r by time gives the velocity or orbital velocity or circular velocity in the case of circular motion. So this is all about the motion topic. We can see in the example that the velocity at each and every instant of time is tangential. As you can see, the velocity is tangential to the circle at this point, and at this point it is tangential to the circle, and at this point it is tangential to the circle at that point. So wherever you see the direction of at that particular time, instantaneous velocity is tangential to the circle at that particular point of time. So this is what uniform circular motion is all about, right? So I think you students are now thorough with some of the basic concepts of motion, and you can use them very much in the exams. Right, thank you.